Okay, testing. So, good morning to everyone. So, for this video here, I'm going to start with the discussions on the set question, the set Persiapan. So, we will start from the very first questions here. Questions number 1 for section A, which is come from chapter 8, the chapters of limits and continuities. And let's see how we solve for these questions here. Okay, let us start. In these questions here, what is given to us is that we are given that the limits for the functions g x multiply fx over x minus 4 equals to 15. Wait, let me put it in the full screen. Okay, so you're given that the limits of gx fx over x minus 4 is equals to 15. Then limit x approach to 5 for gx equals to 3. Both the limits here is referred to x approaching to the same value. Then they ask us to find out what is the limit x approach to 5 for fx. And your information is these two piece of thing on top and how we can get the answer. So our clue is that we try to, from this info here, to get out the answer for fx. And we can do so by using properties of limit that we will see later. Then to calculate this part 2 limits here, we have limit x approach to 5, x squared plus 2. And in order to solve these questions, the second limits here will be helpful. Then B, you were given a piecewise function. Then we want to determine whether does the limit exist or not. Sorry, we want to find this limit value if let's say it exists. So in this case here, how we're going to solve is that we try to check for the case of -1. Does that happens that the left hand limit and right hand limit for this value in the piecewise function use different function? If they use different function, then we need to calculate each one of them separately before we go for the decision whether x approach to -1, the limit exists or not. So therefore, let us see our solutions here. For question A, now what we have is that we start from this info as I copy it back, then reach up to here. What I would like to do is that I would like to apply the properties of limits, where if let's say in this case here, x approach to 5, and let's say I have the item as a over b, the function is a, the function is b, then I can break it become limit x approach to 5 a over b. And this is what happened in the later step. Then we also want to apply the properties if let's say I have the case of, let's say a multiply b. Sorry, I think I made a mistake here again in the writing. So once again, if limit x approach to 5 for a over b, then I can have by properties of limits x approach to 5, top and bottom, a, b. Similar for the case of multiplications, then I have limits approach to 5 multiply with limits x approach to 5, where the AB follow each of the limits for multiplication. We are going to do this for the next part of the calculation, where in here, I show you step by step of the calculation is that from here, go for the next step. What I would like to do is that first, I would like to break it in the form of, for the left hand side, I will break it become limit gx fx divided by limit x approach to 5, x minus 4 equals to 15. So this result here is obtained based on the idea of these properties. And then next, I want to apply the properties for the one that I highlighted in blue on this part here, where I will break it become limit g multiply limit f divided by limit x minus 4. And it will equals to 15. And reach up to here now, you should be see very clear that the subject that we want to find, limit fx, is there. And in order to get this answer here, I need to evaluate out what is the answer for these two limit I highlighted in green. And as you can see from the information, limit x approach to 5 for gx is equals to 3. So this part here, I can just plug in with 3. The bottom, I just can do direct substitution onto the limits to get the answer. And therefore, the following result I have is this one. So therefore, I will have my answer as follow. And then by the time I simplify my answer, the denominator become 1. So it will be 3 times limit equals to 15. So I have limits equals to 5. Go on. Next. The next questions in part A part 2, where we would like to find out what is the answer for these limits here, where I have x approach to 5, x squared plus 2 over gx. And in order to get these limits here, again, I need to use properties of limit to help me. And the properties I'm going to apply here is that if let's say I have limit x approach to 5, I'm going to break it from a over b. I'm going to break it become limit x approach to 5 over limits x approach to 5 a b. And as a result in the breaking, this is what I have. And therefore now, in order to calculate these limits here, after we use properties of limit break into two parts, you find out that the top part I can solve by direct substitution. The bottom I just do substitution of 3. And therefore, this is the result that I should have. Go on. Next, on question B, to find the limit x approach to minus 1, and if it happen to exist, we find this value here. So therefore, it may be possible that this limit does not exist. And how to determine the answer here is that first, since it involves of a piecewise function, let us try to see this minus 1 here. Is it happen to be the borderline value of the piecewise function here? And we see, yes, it is. It is a borderline value on the x value here. So in that case, I need to further investigate what is the function being used for -1 minus and -1 plus. We find out that -1 minus is the first function, -1 plus using the last function. The middle one, there is nothing do with this calculation of limits lah. So please don't misunderstood that limit for hx here, you substitute hx with x plus 2. This is not correct. Again, you don't assume that these calculations of limit for hx is being calculated in the way that you use the middle function, x plus 2, where you see is -1, so follow -1. That is not proper. This is very close to -1, but not exactly -1. Exact -1 is x plus 2. So in this case here, we calculate the left-hand limits, -1 minus. So the function is 3 minus x squared. Can solve by direct substitution, and we have the answer equals to 2. The right-hand limits, -1 plus, is a limit approach to -1 plus for the function of 4, a constant function. So limit for constant function will be the value, the constant itself, 4. And now we determine the limit approach to minus 1, minus 1. So consider the figures that you have from the left-hand limit and right-hand limit. We find out that they are not the same. So the limit x approach to -1 does not exist in this case here. Then we proceed further. Question number 2 in section A. So these questions, the marks allocated is 9 marks. We have 4 marks and 5 marks. And let's see what we have in the questions here. So you are given H is a composite function of PQ. And with the info of P prime minus 4 equals to 5, Q prime 1 equals to 3, Q1 equals to minus 4, what is the answer for H prime? So in order to get this derivative answer here, you need to know how to do differentiation, how to do differentiations on composite functions. And then you substitute the value accordingly to get this H prime 1. For part B, you're given fx equals to cos 2x plus 1. They want us to show that f bracket 4x equals to 16fx. And what is this term here is actually, we are going to differentiate for 4 times to get the fourth derivative. So for information, f prime first derivative, double prime second, triple prime third, but we don't do 4 prime. So therefore, I will need to write the other symbol. So therefore, in this case here, what I need to do is that I just need to try to do the differentiation until the fourth derivative, and then we try to see how can we relate with the fx to get this proving here done. So therefore, as a result, what I have now for my answer is that for part A, we notice that hx is a composite function of p composite q, and p composite q can be written in this form here. I would like to change into this form here so that it will have a clearer vision to you on how to do the differentiations. Okay. So for the differentiation of composite functions, the idea is actually applying chain rule, but in here I'm not discussing in details on how the chain rule is going on, but you can try to roughly figure out by yourself lah. Let's say you have PU where U is equals to some other things, let's say GX. So when the time you differentiate for PU, it is actually you are doing differentiations of PGU, GX, sorry. Then from there, you find out that the differentiation of this one, you need to use chain rule, DU, PU. Okay, I think fine. I just show you how the formula is being derived out just for explanations. Okay, so let's say in this case, I happens to let the case of u equals to qx. So when the time I want to differentiate with respect to x for the case of p composite qx, this is actually equivalent to the case of differentiate pu. So to differentiate with respect to x for u cannot be done. I need to differentiate with respect to u on u. And this differentiation, I need to balance back with multiply with du dx. So what you happen to find out now is that you have the result of p prime u multiplied with du dx. So what is u here? U is qx, so I have p prime qx. Du dx is differentiate this one, so I will have du dx equals to q prime. And therefore, this is how I get this formula here when the time I differentiate hx, where hx composite of pq. So as a result now, if you're able to do these differentiations, now you can calculate h prime 1 by substituting x equals to 1 inside. So I have h prime 1, p prime q1 multiply q prime 1. Q prime 1 and Q1, I can substitute the value accordingly. So this is the result I have. Now P prime negative 4, I will have the answer as 5. Further substitute, I should get my answer 15. So this is how I get my result. Okay. If let's say you see these questions during exam, don't get panic, but by right, you try to search from the formula list in front. Maybe they will suggest you that how to get the derivative of the case of composite functions. Then you just use if the formula is there. Like what as simple as I have in my solution here. Go on. Question B, we would like to go for the proving. Show that the fourth derivative equals to 16 fx. So anyway, I need to figure out what is the answer. What is the answer for the fourth derivative first before I can proceed to get this result. Somehow I need to differentiate for 4 times first before I get this result. And before that, I need to recall on the knowledge. I want you to recall on the knowledge on how to differentiate cos and also sine. The framework for cos is like this. So when the time you differentiate cos, 2 things you need to consider: the change of the trigo, and then we multiply with the differentiation of the angle. Whereas if let's say I want to differentiate for sine, I need the knowledge on differentiate of sine as well, because later it will involve a sine for differentiations. So it will be changing the trigo ratio become cos multiplied with the differentiation of the angle. Okay. So what if now the hashtag according to the questions is regards on 2x plus 1? So if I consider differentiates with respect to x for cos as follow. Differentiate with respect to x for cos for 2x plus 1. What will happen for the result is that I will switch the sign of the switch the trigo to become negative sine, angle maintain, and then I multiply with the differentiation of the angle, which is 2. So as a result, I have minus 2 sine 2x plus 1. So remember this result, we are going to apply it later. Whereas for differentiation of sine, if let's say the angle here is happen to be 2x plus 1, so I will have it as cos 2x plus 1 multiply with the differentiation of the angle, which is 2. So I have it as 2 cos 2x plus 1. So with this info here now, let us start our first derivative. So we have f prime. We have f prime equals to, so switch the cos become sine, like what we have below here. Switch the cos become sine, and then multiply with the differentiation of angle. So this is the result. So your answer can just as simple as one line answer like this. Then the next result for the second derivative, focus on this part here, we do differentiations. So I suppose if according to the result I have just now, if I differentiate this part highlighted in blue, I suppose I have the answer as 2 cos 2x. So the process here is actually minus 2 multiplied with 2 cos 2x plus 1. But of course, some of you are advanced enough. This step here in green, you don't have to write it down. Then you will get the answer as direct like this. So this is what we have for the differentiation result. I skipped some step there. There is one step here missing for the differentiation process before to get this result. Then further, for triple prime, what I will have is that, again, if I try to do differentiations, what will happen is that I differentiate the cos. So for the result of the differentiation will be minus 4 multiplied with differentiation of the cos. Just now we find out that the answer is minus 2 sine 2x plus 1. So if we multiply it, I have the result as 8 sine 2x plus 1. Finally, we differentiate one more round for the fourth derivative. The fourth derivative. So now we differentiate sine again. So I will hit 8 multiply. The differentiation of sine here will be 2 cos 2x plus 1. 8 multiplied 2. I should have the result as the following. And therefore, this is the fourth derivative. And reach up to here now, I already got my fourth derivative. It's time for us to consider how can it relate with this proving here, which is we try to relate with fx. And somehow you find out that this part here is actually the fx. So we just replace it become fx, and then we have done the proving, as simple as that. So we have done the proving shown. Go on. The next questions, sections A, question number 3, which is the question from chapter 10, application of differentiation. And let's see what is the questions given here. So in this question here, you are given the functions, and you was told that this point is on the graph. So if let's say like this is the graph, then the point is somewhere on top of the graph. Okay. Then next, show that this point is a stationary point of fx. So how can we show that it is a stationary point? We need to think about what is the criteria for stationary point. So the criteria for stationary point is that we find out that we have our f prime should be equal to 0. So now we put a question mark here. Can I get f prime equal to 0? If yes, I done the proving. If can't, then I fail the proving. So in this case here, what I do is that no matter what, I need to find out what is the first derivative for our functions. So I will have f prime, differentiate, I get minus 3x squared plus 12x minus 12. Then with this first derivative, what we go to do now is that we try to substitute from this point here, we try to substitute the x coordinate inside and try to see whether can I get equal to 0 or not. So as a result, for the point 2, 3, when the time you substitute x equals to 2 inside for the first derivative, I get f prime 2. I have the result as negative 12 plus 24 minus 12. The answer is 0. So I find out that f prime 2 is equal to 0. Therefore, I can come up to the conclusions that 2, 3, the point 2, 3, which is on the graph, is a stationary point shown. This is how we done the proving. We show that the first derivative equal to 0. Next, they ask us to find the f double prime and hence show that the same point which is on the graph, besides it's a stationary point, it is also an inflection point. So how we do the proving here is that, let's see, the question first asks us to find the second derivative and then hence means that make use of previous result. So this second derivative is the clue for us to do the inflection point. So if we use second derivative to show inflection point, it's actually we want to see is there a change of concavity, whether the concavity is changed from concave upwards to downward or downwards to upwards. As long as pass through the point x equals to 2, the concavity change. And how we solve the question is that first, solve according to the question, find second derivative. By using the first derivative you had previously, you find out the f double prime. So I have minus 6x plus 12. Then next, what we do is that we're going to do the concavity check, the concavity test using the table here below, where we have first start with interval, test value, the second derivative, and then the concavity. So for the interval, what we should use for the interval is that we would like to test on this point here. So therefore, what I will do is that I will use the point here, consider the x coordinates. Then next, I would like to consider what are the interval involved here. I find out that we have first second interval. First is negative infinity until 2, then 2 until infinity. So therefore, this is what we have. Next, we try to choose a test value. In here, we try to choose a test value for further calculation to determine the concavity. Let us choose some simple test value, which is close enough to 2. For example, let's say I choose 0. I choose 3. Do direct substitutions into the double prime. I have the answer as positive, which means that I have it as concave upwards like this. Substitute 3. I have concave downwards with negative. So we see the concavity change. As a result, what we have is that we're able to show that 2, 3 is an inflection point because we see there is a concavity change. So this is how we get the answer. There's a concavity change, then we show that 2, 3 is an inflection point. Go on. B. Section B, question 1. 5 mark is given. The question is direct. They just ask us to express Z in polar form. So in here, be careful on the complex number here for the arrangement. So the questions here, they arrange in the way of they have imaginary come first, followed by real numbers. And the imaginary number, it have the I written in front of the square root of 3. Usually what you do is that you will put the coefficient in front of the I. But today, in this case here, we have the I in front of the coefficient. And the reason why they do so is so that it's very clear to see that the I is not within the square root. Anyway, to solve this question here, to have a clearer visions, I would like to rearrange it back into the form of the real number come first, followed by the imaginary number. So this is corresponding to the form of A plus BI, where I have my A equals to minus 1, the B is equals to square root of 3. Then to find the answer for the polar form, I need to know two items, the modulus and also the argument, and then only I write it in the form of polar form. So start with the modulus. How we get the answer of modulus is that we use the formula square root of a squared plus b squared. So we plug in accordingly. We should get our answer equals to 2. Next, to get the argument, it's important to take note says that when the time you find the argument z, or sometimes we say it as theta, is not the same as arctangent of modulus B over modulus A. In general, secara umum dia tak sama. Where what you find out is that the one that actually equal to this one is the basic angle only. The basic angle that we use to find what is the argument answer. So, what is the basic angle? What is the argument? To have a clearer visions, I would like to use the Argand diagram to do some plotting to visualize what are they and how we plan for our calculations. So in here, with the real and imaginary part that we identify, we put it inside the Argand diagram for imaginary, for real. So real -1, that means maybe somewhere here. Imaginary positive square root of 3. So I suppose maybe somewhere in here. So this is the location of the complex number z. And what we do next is that from this point here, we join with one straight line to the origin. This straight line here is actually the line of the modulus. The length of this line is actually the modulus value we calculate out just now, which is 2 units. So now from the diagram here, let us try to identify where is our argument. So the argument is actually the angle that we rotate from the positive side of the real number axis all the way to the diagonal line just now, which means that this is happen to be our argument. And please be aware, the rotation of the argument here must be always happen to be have the size of less than 180 degrees. You can rotate clockwise or anti-clockwise, but make sure the size is less than 180. And as you can see here, the size of this angle is less than 180. Then after you identify your argument, the next thing what we like to do is that we would like to find out what is the alpha to help us to get the answer for argument. And what is the alpha is actually referring to the full length of the real number axis and also the diagonal line. Refer to the diagonal line and the full length of the horizontal axis for the acute angle between them. In this case here, the acute angle is this one, alpha. The angle that is below 90 degrees between them. And if you realize this alpha here, there is no directions. You just have magnitude. So in your calculations, in the basic angle, that's why you see why they have modulus, because we want to ignore if there's any negative sign happens on the real or imaginary part for further calculations. So reach up to here. Now we continue. How we get the answer for argument is that we find out alpha plus argument is actually equal to 180 degrees, which is pi. So if I just want to get the answer for argument, it will be pi minus alpha. And also, this is magnitude. I need to consider what is the direction. So in this case here, the direction is in positive directions. So argument, I need to consider two things, direction and also the magnitude. Direction, positive direction, magnitude is pi minus alpha. And now complete our calculation. Start with the value of alpha. We have arctangent square root of 3 over 1 again. The one originally had negative sign, but how come here we don't put the negative? Because we obey the formula that we don't want the negative sign from the modulus. The modulus is trying to tell you that get rid of the negative sign. If you already get rid of the negative sign, you don't have to put the modulus anymore. Therefore, arctangent of square root of 3 will be pi over 3. The answer here must be in radian. Then what we find out just now is that the argument is actually pi minus alpha. According to what we figure out just now, direction positive, size is pi minus alpha. So overall, I have pi minus alpha. So pi minus pi over 3, 2 pi over 3 will be our result. And now combine all this answer into polar form. So how does polar form looks like in the writing is that we have r multiplied with cos theta plus I times sine theta, where theta is the argument and then r will be the modulus of the z. So as a result, we combine the answer. There goes the answer. That's it for B1. For section B, question 1, this is how we get the answer. Proceed further. We go on with question 2 in sections B. So these questions here, number 2, is come from chapter 2 for the case of equations, inequality, and absolute value. So what is being tested in this question here is that we have two inequality to solve, and both of the inequality look so scary with log, square root, and also exponent. And let's see how we solve both of them. And take notes, the answer that you need to put in is in the set notation. So besides you know how to solve, make sure your final answer put into set notations. And we start with the first inequalities. So to solve these inequalities, maybe at this moment here you are blank, you don't know what you can do in order to solve, but try to think, to think and see what are the things that you can do here. We try to do something instead of leaving it blank. So first of all, we see that we have two square root terms there that I can actually expand to become this following result. When the time I expand, it becomes 7x minus 4. And how you get this answer here is that recall back on these properties, the algebra here. M minus n multiply m plus n it will be m squared minus n squared. And in this case here, the m is square root of 7x, the n is equals to 2. So m squared, 7x, n squared is 4. This is how we get the answer. Next, recall on the law of log for this part here. What is the law of log I want to recall here is that if let's say you have log to the base a, the content inside is also having an index with base a, then whatever it happens on the power of this content here for the a, therefore it will be the result of the log. So in this case here, the result of the log will be the power of x squared. So therefore, the next line I can simplify the result until like this form here. Then you happen to find out in this case here, it turned out to be a quadratic inequalities. Let us try to rearrange it. I suppose I have the answer as follow. 3x squared minus 7x plus 4 less than 0. And how I get that? So check out properly. If let's say I rearrange first, I try to have this one move to the left hand side. This is what we originally have. Greater than 0. Then the whole thing here we multiply with -1 so that I can have the x squared come with positive coefficient. Then the rest follow through. And remember the sign is changed. Then I solve this question by using the very classic way. I do factorizations. And then I use graphical method to solve. So by graphical methods, I will have the result as follow. Based on each of these factors here, I find out that I will have a smiling face curve. Smiling face because the x squared is positive. With the intersections here on the x-axis, on the horizontal axis, as the value of 1, 4 over 3. Because here contribute x equals to 4 over 3, 1. And now what I want is I want less than 0. This function here less than 0, therefore I'm looking for this part of the graph and the corresponding angle for this part of the graph. The corresponding x value for this part of the graph is the part I highlighted in red. And as a result, this shading here, we make it 2 in 1. It will look something like this. And our answer will be in set notation between 1 and also 4 over x. Check. In your writing, you must start with the unknown x first, dot dot, and then tell the condition about the x in the inequality form. So this is how we get the question on A. And I suppose that actually after you get this answer here, you need to have a very quick check, this answer here, to have a very quick check whether the x value, does it fulfill the original x value in the log and also in the cert. We find out that the conditions for the x value to be valid in this case here, for the case of cert, for these inequalities to be valid, the x must be a positive value, must be greater than 0. So you see your interval, yes, is located in positive value. Therefore, it valid. The second one, power of x squared by right, there is no specific conditions because x squared, it can be how to say, if you have x squared, so no matter is positive, negative, or 0, the result that you power out is always 0 or positive, and it's always valid for this log equations, this log term here. So there's no issue on this part here. The only condition we need to fulfill is I want to have x greater than 0, because to make these two square root valid. And our final answer, yes, it fulfill. So therefore, we just have our answer as follow. Next, on B. So in these questions here, again, we have exponent and log. It looks so complicated to us, but let us try to do things that we know how to do, where I find out that first, if I exponent a plus b on the power, it can be written as e power of a multiplied with e power b. So this is the first properties that I want to apply to help me to solve the question. Beside that, if let's say I have an index term with a base a, power of a log with which coincidentally also base a, and if let's say the bracket here is hashtag, then the result will be just equals to hashtag. Condition in front of the log, we don't want to have any number. And with these two info here, we should able to start to solve our question where, watch out, the top here, e power of x plus ln x squared can actually break into the part of ex e ln x squared. And then the inequality sign, by right, there's nothing changes. So it will still less than 0. At the bottom, what happened is that you find out that I do factorization of the common terms, where the reason I want to do factorization is because it will be very helpful later to determine the answer, to solve the inequalities, and at the same time, you can able to see lah, these two exponent terms can be cancelled off. And please be aware, I can easily cancel off the exponent term is because I'm very sure that e power of x will never ever equal to 0. And it always happens to be positive value as well. So that's why I can just simply cancel like this. Okay. So what if let's say the term here is negative? Can we just cancel top and the bottom? The one we will see when the time there is example there. But in this case here, the main thing I want to emphasize is that we can do cancellation is that the exponent term is not 0. That's why you can cancel top and bottom. And go on. Next, after we do cancellations, at the same time, I want to simplify this part here to become x squared. And then the bottom I have x multiply x minus 2 less than 0. So reach up to here. What I have is that I have an inequalities that looks like x squared over x minus 2. And then in this case here, by right, I can do cancellation of the x top and bottom because by right, in order to the for the function to be defined, again, x shall not equal to 0. If x can be 0, therefore, these calculations here cannot be proceed further as the function is undefined. So therefore, now it can further simplify to become the following. And by the way, just precaution step lah. You need to be aware if let's say you want to do cancellation of the terms top and bottom, you must have the corresponding conditions. For example, if let's say I have x2 over x2, I want to do cancellations. From here, I want to do cancellation top and bottom. I left the answer 1 over x, then I need to consider also the condition that x minus 2 shall not be 0 to further calculate where x shall not equals to 2. I need to stick with this condition to allow us to do further calculations. However, in our example here, you see that I doesn't really specify to emphasize this condition here in my further calculation is because coincidentally in these questions here, we can see that the x cannot be equal to 0 in these calculations. Go on. Reach up to here. It's up to your choice whether you want to solve these inequalities using real number line, table of sign, or even the shortcut, whichever alternative that you have able to find out lah. But in here, again, I'm using the classic way where I'm going to use number line to help me to solve. Where in number line, what I will do is that I consider each of the linear factors I have, and then I make assumption. I let again. I let is an assumption. This is assumptions. not solve directly, but we do assumption to help us to do some step to further solve. Kita bukan dari sini terus rearrange to get answer, but we try to make assumption to do some algorithm, then get answer. So in here, I will let each of the factors here to be greater than 0. So why we always make it greater than 0 is to draw positive region. Kita nak lukis positive region. So between these two inequality, we find out that x minus 2 can be rearranged become x greater than 2. And now watch out step by step of my calculations. I will start with a horizontal line. Sorry, I will start with a horizontal axis. If I want to label, this is supposed to be x. Put in the borderline value that you have. So we have 2 and also 0. Okay. So watch out, guys and girls. First, I want to draw the inequality x greater than 0. So this is x greater than 0. And the arrow I draw is actually, I'm drawing the positive region. I'm drawing the positive regions. So these are the positive regions. After you're able to identify the positive regions, the rest of it automatically we know is negative regions. So the rest of the region that is no arrow, we do negative. So once again, what I mean here by drawing positive regions is that, what I mean by drawing positive regions here is that I draw this part here. Then after drawing this part here, I label the negative side as well. So this is the purpose why we make it greater than 0 to get this result for drawing. Follow the next inequality x greater than 2. So this is the positive regions, where once again, I highlight the one in blue. I'm drawing the positive regions. Then after I draw the positive regions, I label as well the negative regions. Combine the sign to have our conclusion. So how we combine the sign is that, if you realize, the first arrow that we have just now is come from the factor x. The second arrow is come from the factor x minus 2. And the conclusion we want is that we want to combine these two in divisions, like what we stated on the left hand side. So negative divided by negative, we have positive, negative, positive. So the result will be as in the diagram here, in a better drawing. And we choose negative because we want it less than 0. Therefore, the answer will be 0 until 2, open bracket, in set notation like this. Okay. So in this writing here, using real number line methods, make sure you always mention the assumption. Make sure you always remember why you always let greater than 0, regardless whether here is greater or less than, because you want to draw positive regions. Okay. Then before we go on further, if let's say the number line method is very confusing for you, you always make mistake in your calculation, then maybe I suggest that we try with alternative methods. But there's a risk there that maybe this alternative methods is not accepted because it's not yet officially announced that it's accepted. So we can do the calculation in this way using another form, a mutated form of table of sign. I use the word mutated because I don't use the word like improve. I don't use the word improve or upgrade because this method here may not be accepted, but somehow that the calculation is much easier to get the answer. So first of all, I need to refer to the factors here to find out when each of these factors here equal to 0, what is the answer for x? I find out that the top one gives us 0, the bottom one gives us 2. Take these two values here, put into the number line for us to identify how many intervals that we should have in our calculation. And the mutated table will start in the way that we have interval. test value, and then conclusion. The conclusion here will be the whole term here on the left. Interval, according to this three interval, I have negative infinity until 0. Sorry, let me write down the interval slowly. So let us put in the figure here first. Always start from infinity until 0, 0 until 2 for the second interval. Then at last, 2 to infinity. We list out the number here now. We determine the brackets. Whether we use open or close for this table here. So check. Infinity always open. Denominator is always open as well. Then for numerators, we try to see the inequality sign here got equal or not. If no equal, open as well. So everything open here. Choose test value, -1, 1, 3. Plug this one into the function here below to see the sign that you have after you substitute. It's a positive or negative sign. Then you find out you have positive, negative, positive as a result. After you calculate this function here, use the test value. And therefore the answer will be the negative one. So you have the answer in set notation as follow. So this is how we get the answer for part B here. Again, important to take notes when the time you do cancellations in the calculations here. Why on these two parts here, I can just cancel EX, I can cancel X, because the reason is I'm very sure that the EX cannot be 0. The X also cannot be 0. That's why I can do the cancellations. Go on. Next. We go for the next question, number 3 in section B. This question regards on chapter 5, functions and graph. So you are given the function f and also function g. They ask us to find composite. Hence, based on the result of your A, state with reason whether the function f and also the function g are the inverse of each other. If you say they are inverse of each other, what is your reasoning? If they are not, what is your reasoning? Then state the largest possible domain of f so that f and g are inverse of each other. So it seems like in part C here later, after from part B, whether you determine is this inverse of each other or not, we need to further investigate what is the largest possible domain so that f and g are inverse of each other. And the answer here is just write down direct answer because they use the word state. Then now we start with our solution for question A. So we have f composite g first. What is f composite g is that we substitute function g into function f. Then replace the function g accordingly. Square of square root, I will have the answer as x minus 4 plus 4. Result equals to x. Then what is g composite f? The next thing, substitute f into g. So this is the result that we have. Further, you substitute the x. So you substitute the fx. So we have x squared plus 4 minus 4. Result is square root of x squared. And please be aware, square root of x squared, in general, the answer will just equals to modulus. Square root of x squared is equals to modulus of x in general, secara umum. Unless you have a specific condition, for example, square root of x squared is equals to x. If let's say x is greater than 0, we have specific condition. Square root of x squared equals to negative x. If let's say x is less than 0, specific condition. But according to this question here, there doesn't have specific condition. Therefore, in this case here, it means that it will come back to general, so we have modulus x only. And by the way, for these definitions here just now, for the specific case, both of the case I can have it equal include zero. Kedua-dua pun boleh equal to zero. Then B. Now we want to state the reason whether they are inverse of each other or not. So my answer is that they are not inverse of each other because FG and GF is not the same. Very obvious just now. Modulus X and also X is not the same thing in general. Unless you have a specific situation or specific interval, then only they are the same. So now we find out that B, they are not inverse of each other. They're not inverse of each other. Therefore, next we want to find out what is the largest possible domain so that they're inverse of each other. But before we go on further, just make sure you don't misunderstood that. Okay, if some of you may have misunderstood that or write in this way that F composite G equals to G composite F. Therefore, you will say that F and G are inverse of each other. So for your information, this statement here adalah salah. Ini adalah salah. Kenapa salah? Because sekadar equal saja tak betul. Dia mesti dua-dua pun equal kepada X. Which is means that yang betul-betul correct one is that when both of the composite is supposed to be equal to X. Then baru we come to this conclusion. So maybe this answer here, I would like to make some adjustment. I'm not supposed to make them both of them equal like this, but instead to have an even clearer idea, I should say that the composite of GFX is not equals to X. That's the reason why it is not inverse of each other. So this part here, I would like to modify the explanation, the reason. Go on. So if they are not inverse of each other, is it possible to make them inverse of each other? And how is it possible? So in here, we determine how to make them to happen to be inverse of each other for both of the f and g by considering the domain of f. So in general, the function of f, we have graph looks something like this with a minimum point at x squared plus 4. Sorry, the minimum point will be at 0, 4. We find out that for this graph here, it will be the case of inverse if let's say I only have the part that I highlighted in green or the part that I highlighted in blue. So either one part of them I have only, that is a case of the F inverse exists and then F and G are inverse of each other. So either part of it will do. And which part supposed to be the answer is that for your informations, the answer will happens to be 0 until infinity only. So why? We can have a very quick look on the diagram. If we try to sketch the graph, why not the green? Why must be the blue part? 0 to infinity is because if you try to sketch the function of g, you find out that the function of g will happens in this way here. This is the graph that I have for the g. So if I want to have my function of f is inverse of it, then I must make sure I have a symmetry, I have a mirror image of this along the line y equals to x. So kalau you tengoklah, I put in the graph quadratics of the quadratics. So it will look something like this, cut at 4. So this is the part that I highlighted in green. The other part is the part I highlighted in blue. Either the blue or green, that then we have either we have only the blue or only the green. I can make the F inverse exist. But in here, the F inverse that I want it to exist is specifically to this function here, gx. So in terms of graph, between the one in blue and green, I find out is the one in blue is looks symmetry to the one in the one that looks symmetry with the function g along of the line y equals to x. Ini dua baru symmetry, and this is the properties of inverse. Therefore, your answer for domain is 0 until infinity. Bukan yang sebelah hijau ini, dan bukan simply belasah positive answer. And what is the meaning of the largest possible is that saya nak cover lah sebesar mungkin lah, so that the both of them are inverse of each other. Kalau tidak kan, you seolah-olah boleh consider sini dan sini sajalah. Dia adalah inverse of each other, then you bagi pelbagai jenis answer of domain. But the largest possible hanya ada satu. So therefore, the answer is 0 to infinity. Continue. Question number 4. In section B, question number 4, marks given is 40 marks. Is also regards on chapter 5. And let's see what we have in the question. First, you're given function h. And then they ask us to use the properties of inverse function. Show that hx are inverse of each other. So what is the properties of inverse function? So for information, the properties here we are referring is that when the time, let's say I have the function f composite of inverse, the result is x. Inverse composite f also equals to x. This is the properties we are referring. Dan bukan minta you pergi kira keluar h inverse and then kata yes, they are inverse of each other. Tapi guna composite punya idea saja untuk dapat jawapan. So what we're going to do now is that to prove that this is inverse of each other, I would like to start with H composite itself and see what is the result. And by right, the result, if the bracket here is x, the result should be x to complete the proof. If I don't get equals to x, then should be they are not inverse of each other, and the proof here will be failed also lah. Next, we consider Hnx represent H composite itself for n times. For example, if I write H2, that means H composite 2 times. If let's say I have H3, that means H composite itself for 3 times, so on and so forth. Now they say deduce. Deduce, that means by right, dia bukan libatkan kiraan yang panjang lebar, dia berdasarkan observations, and the observations here we will refer to the previous result. We will refer to the previous result to help us to get the answer. And how we solve this, we'll see later in our solutions. Then part B is another independent questions. We got composite function gf, f, and they ask us to find g inverse, g composite f inverse inverse, with the condition you cannot find g, cannot find f inverse. And how we're going to do that, let us try to analyze it later by the time we try to solve question B. And now we start with A. So as we mentioned just now, to show that H are inverse of each other, we're going to use the properties of inverse, where we will start with, we try to composite H and H itself. So what is this composite? Means that we substitute function H into H, where all the x term here in the function H, we're going to replace with Hx, and this is the result. Now substitute all the Hx inside here, become x over x minus 1. We put the brackets there because to see that which one is the smaller, which one is the larger fraction clearly. Reach up to here. What I would like to do is that I would like to multiply with 1, and the 1 here will be in the form of x minus 1 over x minus 1. I want to mention the word 1 here is to let you know that how come out of sudden we can multiply something in our calculation, but it won't affect the accuracy of the value is because the value that you multiply is 1. When the time you multiply 1 before and after, the value is the same. But of course, multiply 1 in this form here, not only the value is the same, but the function also doesn't change any form. So therefore, we want to multiply 1 in some other form so that in the further calculation, the result will change to some form that will be helping us solve the question easily. So when the time I multiply x minus 1 top and bottom, the top part here, I can cancel, become x only. The bottom part cancel, and this one multiply with x minus 1. So as a result, this is what I have for my answer. So check for the part that I highlight accordingly. Then simplify our answer. I find out that I have answer equals to x. And since H composite itself equals to x, therefore we say that H is the inverse of itself shown. So again, kenapa ini boleh beritahu kita dia adalah inverse of each other? Because ini adalah properties dia. Tak kisahlah F composite dengan inverse ke atau inverse composite dengan F. Kalau bracket sini X, result adalah X. So sekarang you boleh nampak lah H sendiri dia composite, the result ikut balik bracket. So memang dia fulfill lah the idea here. Next, we would like to find out what is the answer for H4301. So in this calculation, here is deduced. By right, we can observe from previous result to get the answer. And if you refer to the marks, there are only 2 marks there. 2 markah saja diberi. By right, kiraan tak akan panjang lebar sangat. And how we get this answer here is that if you realize what happened in the idea you try to observe, if H itself, it will equal to x over x minus 1. If I have H composite H, which is H2, so by right, I have the result just equals to x. If I go for H3, it's actually H composite with H2, which is actually Hx. So once again, I have x over x minus 1. And you find out that this pattern is keep on repeating in the way that whenever you have Hn is an even number, then the result will just equals to x. So if you're able to observe that, therefore, now you check this power here. Sorry, not power, this composite number here, 4301. So you see that it's an odd numbers. Therefore, the answer will just equals to Hx itself, because once again, even number is x. If let's say here is odd, then it will be Hx. So there goes the answer. Of course, we have another way to do interpretation is that if let's say you find out H2 x equals to x, that means we have a cycle there where whenever we find out this kind of situation, we take this number here as the divisor, take the composite number that we want as the dividend, then we try to do long divisions. And then the remainder will be the number of time my H need to composite lah. So if one, that means H itself only. So there goes the answer. Next, part B. We have the composite function gf and also the function fx. We want to find out what is g inverse, but the condition is without finding g. So if according to the classic way that you do is that usually you will from here solve up the g and then you find the inverse. But today they don't allow us to find out the g, and yet they ask us to from there get the answer for g inverse. So is there some way that we can find out the answer for G inverse without finding out the G in this case here? And the answer here is yes, we can do so. And let's see the solution. We'll begin our solution in this form here. So if you realize both of these terms here, left and right, is actually origin from if I have G inverse composite with G, composite with F. You can interpret in two ways here, where we have the first case, inside the function of G inverse, I substitute GF, or maybe I can have for the composite of G inverse and G, we substitute Fx. Both of them are equivalent to each other. I make it this as a start. And what happened on the left hand side is that we don't have G inverse to substitute GF, but we have GF, so we just substitute the GF inside the bracket for G inverse. So as a result, we have G inverse bracket log x plus 3. Whereas on the other side, G inverse composite with G, the result will just equals to Fx, because based on the idea, if G inverse composite with G, whatever inside the bracket here, that will be the result at the end of the day. So therefore, I will have my result as following, where I substitute my GF and then simplify this part here. And what is Fx according to question is given as x plus 4. So reach up to here, I have the function of G inverse ln x plus 3 equals to x plus 4. But my main objective here is that I don't want to have G inverse ln x plus 3. I just want to have G inverse x. So the strategy to solve this question here is that let us try to reduce the bracket terms here into one single variable. So therefore, let's say I let m equals to log x plus 3. So by right at this moment here, I have this one. I notice that the top part here will turn out become G inverse m. Then equal to the x plus 4, I cannot remain as x plus 4 because I have turned the function in terms of G now. Sorry, I have turned the function in terms of m now. So I need to have something m here also. So how to relate x here with m is that from the assumption let we have, we do rearrangement, we find out that we have x equals to e power of m minus 3. Now I can substitute the x with the m term as well. So this is the result I have. And finally simplify em plus 1 as the result of the inverse. And this result is everything in terms of m. We don't want. We want the final answer in terms of x. So all the m we replace with x. We have done the answer. Go on. Question B. We find out that we have a similar situation like just now, that they don't allow us to find inverse, yet they want us to find out this answer here. So if using the normal way that we do for this question is that I believe you will first find out what is G inverse, and then you go on with composite them, and then you go on with the inverse. You will go through this process to get answer. But today they don't allow us to have this one. How can without this one I get the final answer? So I need you to recall back on the properties on the inverse and also composite function. If let's say function h composite function k inverse, the result will be equals to k inverse composite h inverse. This is the one that we are going to apply. And also one more thing, if let's say I have the case of let's say p inverse it again, so the answer will be p. So this is the clue that we want to use for our calculations, and as a result, G composite F inverse will equals to, so let us check slowly. If according to this idea here, I should have F inverse composite with G inverse. And F inverse is actually F, so we have this one. for the further calculations. Fx is given in the question. G inverse we have found just now. So what you need to do now is that substitute G inverse into function f. Substitute G inverse into function f. And now the G inverse is equals to Ex plus 1. And then plus with the 4 just now, I have answer Ex plus 5. So watch out. We doesn't find the f inverse, but yet we can get the answer for this term here because we use the properties and use the previous result from part A, the part B1 to use the G inverse to get answer. Go on. Question 5. We have these questions here come from chapter 8. The marks is given is 13 marks. 13 marks. And what we have in these questions here is that, let's see. You're given a function, the domain is being told your x is not within 1 to 2. That means from 1 to 2, if we try to sketch graph, this position here is happen to be empty. Bahagian ini tak ada graph. Kalau sini 1, sini 2, bahagian tengah-tengah ini tak ada graph. Mungkin graph somewhere here, tapi tengah-tengah tak ada graph. So now we would like to find out what is the answer for limit x approach to 1 minus and limit x approach to 2 plus. Then we want to state the vertical asymptote. So find out these two limits here, then we state the vertical asymptote. B, find horizontal asymptote, and lastly sketch graph. And let's see how we get all this here done. We start with part A. Limit x approach to 1 minus fx, substitute the functions. So we have x minus 2 over square root of x squared minus 3x plus 2. So in here, try our luck with direct substitutions. So we substitute x equals to 1 inside. You find out that the result on top you will have minus 1. At the bottom, you will have the result as substitute. You will have the result as square root of 1 minus 3 plus 2. So you have the result of negative 1 over 0. So I suppose this result will give us plus or minus infinity. But whether it's a plus or minus, we don't know. We need to have some test value. So 1 minus, let's say I choose the value of 0.99. If I plug it inside, then I try to check whether I have a positive or negative sign. And in this case here, I should have a negative sign to get negative infinity as a result. So the calculation for this one should be simple enough. Then for the case of 2 plus, let us try to see. Substitute the function fx. Then we try to substitute 2 inside for further calculation. And what you happen to find out is that if let's say you try to substitute 2 inside, the result will be 0 over 0. And if I have 0 over 0, that means that there is some factors that is creating the 0 and I need to find it out to do cancellation. Usually this factor here is a linear factors. But for today's this situation, it's not so linear. What I mean by not so linear, let's see. If you realize at the bottom, I can do factorizations to become square root of x minus 2, x minus 1. And then from here, I can further do simplification by cancellation top and bottom to get the following result. Where you find out that how can I do this calculation here is that maybe you can interpret in the way that maybe I will suggest you that this part here, you factorize it become in this form here. Or maybe also we can rewrite it in the form of indices. Then when the time you do cancellation, it will come up to the result as following. So in this case here, we doesn't cancel off linear factor, we cancel off something that not so linear factors, this one, which creating 0. And therefore we have the answer as following. the answer is equal to 0. And finally, state the vertical asymptote. Your answer is just x equals to 1. Where y is just x equals to 1 is because x approach to 1 minus, we get the answer of infinity. X approach to 2, it doesn't give us infinity. So therefore, there's only one vertical asymptote. Must be the result from x approach to some number, the result of the limit is infinity, then only we can state that this is the case of vertical asymptote. If approach to some number, the result of the limit also a number, therefore this is not the case of asymptote. Go on. We continue calculations for the horizontal asymptote. So for your information, horizontal asymptote, we always do the calculation for the plus and minus infinity, approach to plus and minus infinity. So if let's say I start with the case of minus infinity, negative infinity, how you do the question is that, again, substitute the functions. Direct substitution of infinity, you should get the answer of negative infinity over infinity. So in here, we need to divide with the highest power of denominator to solve the question. In here, I should divide with square root of x squared, top and bottom. However, for the bottom, I can divide it easily, but for the top part, I need to convert into some form that is equivalent to it, equivalent to square root of x squared, but it's just in terms of x only. So for your information, square root of x squared is actually equals to modulus of x, and modulus of x can be defined in the way of x and minus x. For the case of x greater than 0, x less than 0. So if I try to extract out the information from here, from the one that highlighted in yellow, and also from the one that highlighted in blue, I will able to find out that in this case here, I find out that for x which is greater than 0, I have square root of x squared equals to x, or we say x equal to square root of x squared. For x less than 0, I have the case of square root of x squared equals to minus x, or we have x equals to negative square root of x squared. So in this case here, I would like to replace the info accordingly, where x approach to negative infinity. So this is the case that I have x less than 0. So this one I should replace with minus x. And in order to make our calculation later much easier to do calculations, I would like to further make some adjustment where the negative, I want to put it at the bottom. So as a result in the divisions, this is what we have. Substitute infinity inside, I have answer minus 1. And by right, this result is good enough to tell that y equals to minus 1 is horizontal asymptote. I don't have to consider approach to positive infinity agree to this value, but this part itself already good enough to tell that it is a horizontal asymptote. Similarly, we do our calculations for approach to positive infinity, substitute the functions, and at this moment here, I find out that my divisions initially divide with the highest power of denominator is square root of x squared, square root of x squared. But once again, the top part is not convenient for calculation, and I realize that I want x approach to positive infinity, which is x is greater than 0. So this part here I can replace with x, and therefore the divisions will happen as follow for answer. And from this value here, we know that we have another horizontal asymptote, which is positive 1. So as a result, your horizontal asymptote is plus minus 1 in this case here. Then proceed. Finally, they ask us to sketch the graph together with the asymptote label. So what is the info that we happen to know now is that we realize that we have limit x approach to 1 minus fx is negative infinity, where this tells us that x equals to 1 is the vertical asymptote. And then further, we realize that limit x approach to negative infinity fx is equals to minus 1. Limit x approach to positive infinity fx is equals to positive 1, where both of these tell us that we have y equals to plus minus 1 as the horizontal asymptote. And now let us try to do the rough sketching before we go for the actual graph to see the procedure on how we get the answer. So we may start our drawing with the x and y axis. We put in our asymptote that already identified. So we have x equals to 1. So x equals to 1, let's say 1. So this is the asymptote that we have. Put in the asymptote first. Y equals to plus minus 1. So we have y equals to 1. We have y equals to negative 1. So these are all my asymptote. And now refer to the figures that we find out from the calculations here, as well as the interval that we don't have any graph there, which is 1 to 2. So let us go on further to identify. So let's say here is supposed to be 2. Therefore, the region now I highlighted in pink, sepatutnya tak ada graph lah. Kawasan ini tak ada graph lah. Kawasan ini takkan ada graph. Realize all the restrictions already from the asymptote and also the value that is undefined. Then now let us look at each of the limits here to get the idea on the sketching. When x approach to 1 minus, I have negative infinity. That means when time you sketch the graph, getting very close to x equals to 1 from the left hand side, the graph will approach to negative infinity. Therefore, I have a tail something like this. Dia pergi ke negative infinity. Nak join balik atas macam mana, nak curve macam mana, itu tak pasti. Nanti baru kita tengok. Then further, this one. When approach to 2 from the right hand side, if you reach the point of 0, that means dia akan sentuh point ini terus. Sentuh dengan cara apa? You will sentuh dengan tinggal dengan satu lubang. Kenapa for sure tinggal pada satu lubang? Because cannot include dua. So akan tinggal satu lubang di sini. Then now we go on further. Approach to negative infinity, I have fx minus 1. So approach to negative infinity, that means we refer to the left hand side here on the graph, is getting very close to minus 1. So how can it happens to be is that sama ada graph saya di atas sini, di bawah sini atau di atas sini. And how to check whether which one is the proper one answer, what you need to do is that you can try to take this function here, you make it equal to negative 1, and then you try to solve with your calculator. You solve your calculator using shift, calculate, substitute some x value that is nearby and try to see whether does it happens to have some figure out. If let's say can't solve, by right, it won't intersect the y equals to minus 1, and therefore the graph will be the one below. And I suppose I suspect, if I'm not mistaken, by right, it doesn't go across y equals to minus 1. This case here is supposed to be can't solve, if I'm not mistaken. Then the other one, approach to positive infinity, is getting very close to 1. So I can possible to have graph on top like this, or the graph below like this. Tapi siapa lebih betul? So buat balik kerja yang sama. Cubalah sekarang kita nak check adakah dia sentuh y equals to 1 ke tidak. Substitute 1 dalam function ini and then shift calculate to solve. By right, it should be can't solve as well. So therefore, I realize that this is the shape of the graph I have. Now try to connect. And here we have a y-intercept, right? Try to figure out the answer. and therefore this is the full diagram of your graph. This is the part that just now we find out in our calculation in the very first part. It is not asymptote, but just a undefined value, a hole here. Continue. Question number 6, chapter 9. So this question is about differentiations. So let's see how we solve for the questions here. You are given the implicit functions. Then they ask us to show that these following equations. Next, find the value of the second derivative when we have x equal to 0. So the hence here means that we can make use of the previous result to get answer. So if let's say you're not able to solve part A, you still can use part A result to do for further calculation lah. But in this case here, it don't seems like it will be very helpful. As you can see, the info I have from part A is that I have second, I have first derivative. If you fail to show until this part here, maybe you fail to find first derivative as well. Therefore, you're not able to get this both of this question here done lah. But anyway, the hint here, the hence hint here is trying to tell you that find this value based on the equation on top below. So let us start with the proving here. How from this implicit functions here get the result as follow. So my answer here as you can see, I doesn't cover anything there. So let me explain to you directly on the uncovered answer to you. So from the equation given, if I want to reach until this equation I need to prove, I find out that I need to try to do differentiations until I have second derivative. Then from there make adjustment. And in this calculation, one important message you need to know is that the question are not interested to know what is the formula for the first and second derivative. That means you tak payah susun dy dx sampai something. Then baru you solve for second derivative, so on so forth. Tak payah. Ini formula tidak penting. Asalkan you boleh capai this equation, you ada dapat formula ini ke tidak, tak penting. And of course lah, if you found that right in this form here will be helpful from your further calculation to prove the equation, you're welcome to do so also lah. But again, it's not necessary actually. Okay, now let us try to check our result here. And in order to be more organized and see things clearly, I would like to highlight with different color for each part that we're going to do differentiation with respect to x later. So you find out that for the one highlighted in yellow, by the time we undergo the process of doing differentiation with respect to x, we have the part in yellow turn out to become ey dy dx. For the one in red, we apply product rules. We have the result as x dy dx plus y, check. U as x, v as y. So you have u v prime plus v u prime. For the one highlighted in green, when the time you do differentiation, I have this result 2 over 1 plus 2x. And how we get this answer here, recall. When the time you differentiate the log terms, it will happen to be 1 over the content inside the log, the hashtag, multiply the differentiations of the content. And in this case here, if let's say I have the situation here as I differentiate log 1 plus 2x, so what will happen to the result is 1 over 1 plus 2x multiply differentiation of the bracket here, which is 2. And as a result, 2 over 1 plus 2x. Finally, differentiates 1 constant, I got 0. So reach up to here, by right, I have my answer now with first derivative. Again, the formula of first derivative is not important, but yet you still need to figure out the best arrangement for you to do differentiation further in order to achieve the answer. So in here, I would like to rearrange in the form that I would like to have the part that highlighted in yellow as well as the x dy dx here as I highlighted in purple now, this whole thing here, factorize out the dy dx. So that in the further step, when the time I want to do differentiations, my calculation will be much simpler. And also at the same time, by right, this can be done at the same time. The part highlighted in green, I would like to write it in index form. I don't want in reciprocal form because in this form will be easier for us to observe for further calculations. So maybe in this solution here, we find out that this third line here, boleh batalkan, ini tak mau lah. Just directly from the one that you see here. We do factorizations and also we change the form. And reach up to here now, we're going to go for differentiations for one more round. So now refer to the corresponding color. We have purple, green, and let me have one more color in between them. Let's say I have it as yellow. So differentiate the one in purple. I need to use product rules. I have my U, V. So the result of differentiation will be the following as I highlighted in purple. So I will have the U, V prime, U as the bracket term, V as the dy dx, then V, U prime. For the part highlighted in yellow, when time you differentiate, you have plus dy dx. For the one highlighted in green, this is the result we have, and how we do so is that we apply power rules. So what is power rules is that if let's say I have differentiate with respect to x, hashtag power of n, by power rules, multiply the power in front, the bracket. Bracket term don't do any changes, just that the power reduced by 1. Then we multiply the differentiation of the bracket terms. So as a result, what you can see is that you have minus 1 multiplied in front. Bracket terms maintain. Power reduced by 1 become minus 2. Differentiate the bracket terms, we have 2. Then the 0, when the time you differentiate, it still maintains 0 lah. Then reach up to here. We try to compare the answer that we want to achieve, this one. We try to compare the answer we want to achieve. You find out that so far in your calculations, the second derivative terms already there. The first derivative square we haven't achieved, but maybe we can get it done by expanding. The first derivative maybe on the way pending. The last term here on the right, maybe I can do something on this part here and in green to get the answer. And finally, let us continue with expanding this part here. So I will have the result as ey dy dx square plus dy dx. The part highlighted in yellow, maintain. The part highlighted in green, I can rewrite it become minus 4 over 1 plus 2x squared. And we are almost there to achieve our final answer, where we try to sum this up, become 2x, 2 dy dx, and then this one rearrange to the other side. Therefore, we have complete the proving. Go on. B. Hence, find the value of second derivative. So, in order to get the answer for second derivative using this equation, you find out that you need to know what is the corresponding y value, or maybe at least the ey value, the first derivative, to do further calculation. So, therefore, before I can just apply this one to get the answer for second derivative, let us consider substitute the x equal to 0 into the equation here on top, as well as regards on this result here just now for the first derivative calculations. So as a result, let's see, we substitute 0 into the function given. So we find out that along in our calculation, we find out y is equal to 0. Then next, we substitute the info of x equal to 0, y equal to 0 as we have calculated just now these two into the first derivative result, which is just now what we have somewhere here, which is I have in here ey plus x dy dx plus y plus 2 over 1 plus 2x equals 0. So we substitute into these equations here with the x 0, y 0. So we have this following result, and it helps us to get the answer for the first derivative. Finally, with all these three info, we plug inside to the equation we achieve on part A. Therefore, this is how we get our answer for the second derivative equals to 4. Okay. Finally, the last questions on this paper here, section B, question number 7. 9 marks is given to you. And this question is about optimization problem where we will have a factory would like to construct a closed cylindrical can with a radius of r centimeter and height of h with a volume of 1080 pi centimeter cube. So reach up to here, what is the info that we know is that we are actually having the situation that we want to construct a can in cylinder form, and this is happens to be a closed can. That means I need to have material for the top parts, for the bottom parts as well. And of course, the side also is being covered by the material. So all those part that I highlight is the part that I need to get ready material to construct it. And I find out that in this can here, I have radius of r cm, height of h, volume is 1080 pi. Then you was told the material used for the top and bottom of the surface costs 0.5 50 cent per centimeter square. So on top, the one that highlighted in blue, the cost is Rm, 50 cent per centimeter square for the part in blue. Whereas for the part in black, the side, we will have the material cost is Rm, 0.2 centimeter square. The material used for the lateral side costs 20 cent per centimeter square. So that means the part that highlighted in red. A. If C equals to the total cost of the material, show that C is equals to pi r squared plus 432 pi r power minus 1. And that hence, find the minimum total cost for the material correct to the nearest ringgit. So how we solve for this question here is that, again, if let's say you fail to do the proving on part A, you still can use this equation here to further help you to solve the part B to find the minimum cost. But let us try to figure out how to solve for the full question here is that first, you need to know how you construct a cylinder. A cylinder is being constructed by two circles, the top circle and the bottom circle, and a rectangle, where the two circle is corresponding to the part I highlighted in blue, the rectangle corresponding to the part I highlighted in pink. So If I want to find out what is the cost to use for to construct this can here, what I need to know is now by using um, the area of these two s- circle, the top and bottom, multiply with the 50 cent, I will know the total cost for the top and bottom. Using the area of this rectangle, multiply with 20 cent, I will know the total cost for the side and sum up everything. That will be the grand total I want to find out from this equation here. So let us see how we get our answer here done. First of all, what is the area of the two circle here? You find out that the area will happens to be equals to a circle surface area is given by formula pi r square. If I have two circle, that means I have 2 pi r square. And in this case here, what is the cost is that I take this surface area multiply with 50 cent. Similarly, for this rectangle, the surface area is actually 2 pi rh, and therefore the cost will be I taking 2 pi rh, I try to multiply with I try to multiply with 20 cent. And by right, I sum up these two, I will have the answer for the cost. But if you realize the final answer doesn't have h at all, it's only in terms of r. That means the h can be replaced. And where can I find something to replace the h here is that I can make use of the volume formula to help me to get the answer to replace the h become r. So after we have the idea on how to calculate the total cost and we notice that we need to replace h, let us try to find out what is the relationship between r and h in this case here using the volume formula. So we find out that the volume formula for a cylinder is actually equals to pi r square h. V equals to pi r square h, and the volume is given by 1080 pi. So 1080 pi is equals to pi r square h. Simplify, we have h is actually equal to 1080 r square. Now, this is the relationship that I can get between h and also r. Now, I suppose to able to calculate out what is the total cost C by using the idea that we find out just now. We sum up these two costs that we figure out, and then the next line, replace the h according to the relationship on top, simplify our answer, therefore the proving is done. So we have the proving is done for the total cost. Then now, next, we would like to find out what is the minimum cost for the material. That means we want to minimize the equation in part A here. And the final answer that we minimize later, we want to correct to the nearest ringgit. That means tak mau sen. Dia mau ringgit saja. Contohnya lah, let's say seringgit, seringgit 20 sen. So round up to the nearest ringgit will be satu ringgit saja. So this is what they want for the final answer. But anyway, let us try to calculate out the figures, then only we consider how to correct to the nearest ringgit. So the calculations is quite routine, where start from the cost functions. We do differentiation with respect to r. So this is the equation I have. And then if let's say you find out that these equations for the first derivative is simple enough to differentiate one more time to get second derivative, you're welcome to do so for the second derivative so that it will get ready for the second derivative test. But if let's say this function here is very difficult to differentiate one more time, then maybe we stick with first derivative. Okay. Anyway, in this solution here, I hold on with the second derivative. I just go on further to find out what is the suspect that will give me minimum cost. So I consider the first derivative equal to 0. Then from here, I try to solve. I find out that the r is equals to 6. And let us see in details how the process of solving happening is that I rearrange the terms to the right hand side. And then from here, what I do is that, watch out in my calculation. First, I would like to divide with 2 pi, which is the common factor on both sides. And then at the same time, I would like to multiply r squared on both sides. So I suppose if I try to see this step by step, I will have the result as following. So when the time I divide with 2 pi, I should have the answer r equals to 216 r power of minus 2. Then the whole thing I multiply with r squared. For power of 3, I can just directly use the calculator to get answer. For the r value is just take the cube root of 216 and the answer will just equals to 6. Odd number power, we can just directly get the calculated answer. It won't give us two possible answer. It will just give only one answer according to what you have from the calculator. So as a result, I have the value of 6, but please be aware, the r equals to 6 doesn't guarantee that it will give you the minimum cost because this is calculated based on first derivative equal to 0. So equal to 0, it may be the case of maximum, it may be the case of minimum. So there is uncertainty there. So to further confirm, is actually really maximum or really minimum, what you need to do is that we need to do tests. And in here, I would like to go on with second derivative test. So I differentiate the first derivative for one more time to get the second derivative. And then for this second derivative, I substitute the r inside for calculation. And I find out that the result of my calculation I have, the result is positive. So this positive tells us that I have the case of concave upwards, which is the minimum case. So minimum exists. And if minimum exists for this situation here, where we see that r equals to 6 is the one that giving minimum, creating minimum. And what the question actually want is that they want the total cost, the minimum total cost. So let us substitute this r value here into the cost formula. So the exact value we find out is actually 108 pi. But since the question wants us to correct to the nearest ringgit, therefore I have the answer as 339. Therefore, the minimum total cost I have is RM 339 ringgit. And please don't convert to 340 and say keep the change of 1 ringgit. Not like that. They want to have the final answer keep in the nearest ringgit, which is means that in this calculation here, 108 pi, if you're trying to use your calculator to do calculations, I suppose this figures here is around 339.29. So to the nearest ringgit, we want to round off this cent here, this 29 cent here. So when the time you round off, it will be 339 only. Okay. So therefore, this is the answer that we have for question number 10. Sorry, question number 7 is section B, the very last question on this set of questions here. So therefore, I will end the video here. Thanks for watching.